Okay, you guys can see PowerPoint behind me, right?
Yes,
Yeah,
sir.
can, sir.
Okay, good. Okay, now recap some important concept when we talk about corrosion. So to make corrosion happen, you need to have the element, the metals. Again, corrosion only happen in metals or alloy. So when it comes to test or final exam or even assignment, just be careful on the given material. Okay, so look for metals or alloy material. Then you need an environment for it to trigger the corrosion process. So in this case, the most basic one, you need water and oxygen. Okay, and then there will be some exchange of electron. Then you get the final products. Okay, in this case, the final products. And just remind yourself that corrosion happen without any external electric. Corrosion happen without any external electric or electricity, right? So if you put in a solution, if you put a metal inside solution, chemical solution, and you supply electric to the positive and negative point, then it become electrolysis already. It no longer fall under corrosion. So this will be, yeah. So just take note on that, lah. Okay. So don't confuse yourself, especially when come to final exam or test one. There will be a tricky question where we will ask you to differentiate corrosion and electrolysis process. Okay. The keyword is corrosion do not need electricity supply, right? The keyword is there. All right. Then we also cover that corrosion. We have nine form. Okay. We have covered uniform attack. We have covered galvanic corrosion. We have covered pitting in our previous class. Today we'll look at the rest. We look at the rest. Okay. Now today we'll look at a new form. We call it crevice. Crevice corrosion. What I mean by crevice? The keyword is welding. So crevice normally happen in welding on the connection area where you use welding. Maybe some in condenser. Especially the connection area, the connection area between metals and metals. Why this crevice happen is because of the solution. Because when you weld, there will be some parts, there will be some part in the area, they will capture the solution inside there. Because you know when you do welding, the metal melt and then solidify, become solid. So the solution capture on the surface, right? So this is why crevice will happen. As you can see here, this is another example from here, and this is under 7,000. The size of this crevice is 7,000 micron, very small, right? This one is alloy 22. When there is a current of 40 milliampere accumulated at 7 Celsius. Okay, so you know that when you do welding, welding means you melt or you change the state of the metals from solid to liquid, and then when you cool down to room temperature, solid liquid form of metal will become back to solid states. And then during the transitions of liquid to solid, it will capture some of the air, some of the chemical products inside the liquid layer. So this is, you can imagine this is surface. So when you do welding, some material was melt and then it will solidify and capture something inside there. So there will be like a small, tiny bubble on the surface, very, very small. As you can see here is under microscope and magnifying to 7,000 micron. Okay. Okay. So this is a Crevice. Keyword is welding. You link Crevice to welding, and then you think how welding happened. Okay. Another one, Filiform. Filiform, the keyword is organic coating, especially humid atmosphere. Let me show you the picture. So as you can see here, this is a photo that, this is what material. Yeah, it didn't say any material, but you can see the scale of the photo is 0.5 meter, 0.5 mm, which is 500 micron, 500 micron. All right, this is a standard. Okay, so filiform means you can see there's like a small river shape in the material. You can see there's a the corrosion color, the brown color, and you will see some shape like what this shape can relate to. You know the tree root, the root of the tree of vegetables. You will form like that. It will be like this kind of shape, and it's because of coating. It happened under the coating. You will see. You can observe this one, but this one you have to magnify it a little bit. What contribute to this filiform is because of the humid atmosphere. Very, very, very small, but you can observe. You will see sometimes you see very small spot of chocolate color on the surface. Then you use magnifying glass. You will see serious one. You will see some shape like that on the brown color spot. Okay, and just take note on the green color statement here. If you have a standard steel, you have a copper on titanium, because stainless steel, copper, and titanium, they are corrosion resistant, so they will not have filiform. So this is also one of the popular area we like to test a student. Sometimes we give stainless steel and we ask, actually it's a free mark question. We just want to see whether you are aware whether these three types of special material, is there any corrosion happen on these three types of material? So just take note on that, right? Stainless steel, copper, and titanium, they are corrosion resistant alloy that do not happen. It's very hard for you to find filiform corrosion. Unless there's impurity inside there, then yes, corrosion will happen. But normally stainless steel, copper, and titanium, you cannot find filiform corrosion happen on them. Okay, other form of corrosion, yes, but not filiform. Just take note on this one. Okay, so stainless steel, copper, and titanium, they do not have filiform corrosion, or they do not experience filiform corrosion. Just take note on that. Next one is stress corrosion cracking. In short terms, in later chapter, when we talk about stress corrosion cracking, we will use SCC, capital SCC, to represent stress corrosion cracking. It defined as a crack growth under stress plus corrosive environment. So from the wording itself, from the name itself, you know stress is something that in this case I highlight the type of stress is tensile stress. You know that when you learn about stresses in your FEA, finite element analysis, or in your engineering courses, you know that stresses, you have tensile stress, you have compressive stress, you have torsion, you have bending. All right. So this type of corrosion, stress corrosion cracking, you need two factors. One, simultaneous tensile stress means you need to pull it. Okay, you need to pull it. So simultaneous tensile stress plus corrosive environment. Then on metals again, corrosion is linked to metal. So just remember for SCC, it linked with stress, and type of stress is tensile stress, the pulling one, the pulling stress. Because when you pull the molecule, the element or particles in the linkage in the metals, they become separate a little bit because you are pulling, right? Separate a little bit, and there will be something happen between the distance of metals molecule. Okay, so and then corrosive environment, acid come in, and other corrosive element happen, then SCC happen. Okay, so just take note on the point on SCC. Okay, so this will be the phenomenon that you can observe. Okay, this one is more, this is a very extreme example. Means if you see this one already, you need to change the whole component. It cannot be used anymore, right? This one, because of under stress and corrosive, you will see micro crack on all these areas, right? All right, means this part is sustained tensile stress pulling up, or maybe this part pull down. So this part will go up and down, so it becomes tensile stress. Tensile means you pull both ends. Then you're exposed to corrosive, then you have a micro crack happen, and it will propagate. Propagate means it will, the micro crack will become a big crack. Okay, so this is a very interesting phenomenon, and it will happen when you go to work later on, especially when you are stationed in the quality control or equipment maintenance department. Then you need to be careful on SCC, or even you work as a design engineer, you need to consider SCC. If you work in the petrochemical company, for example, Petronas or Shell, those that are exposed to tensile stress and corrosive environment, then you need to be careful in your design. All right. This one, just for info, this one is for that standard steel. Again, standard steel will not experience filiform corrosion. Just take note. Standard steel, copper, titanium do not happen filiform. Okay. So we have covered type of corrosion. Let's review. Let me ask question whether you understand or not. Let me check attendance. Okay, I'm going to ask question. This question go to Mohit Nathan. Mohit, are you there?
Yes, sir.
Okay, Mohit, what do you understand about uniform attack?
happens like invisible, right? So that it attacks the whole the surface of the metal, like it it grows like evenly.
Okay, correct. You have mentioned the keyword evenly. Okay, the keyword is evenly, and then even you can draw the diagram for that one. Okay, good, very good, Mohit. Another one, Darshan. Darshan Mitra. So, what do you understand about galvanic corrosion?
Can you hear me, sir, now?
Yeah, I can hear you. Yeah, go ahead. What do you understand about galvanic corrosion?
Corrosion basically can have the positive and negative electron movement. That's where the galvanic corrosion happens.
Correct. So the keyword is you have a positive and negative uh, pole, or you have an anode, a cathode, or there is a flow of exchange of electron. Right? Very good, Nashan. Logeswaran, what mean by okay? Beating is very quite direct lah. Crevice corrosion. What do you understand about crevice corrosion? Logeswaran. Calling for Logeswaran.
Sir, my line's a bit bad, sir. Can you hear me now, sir?
Yeah, go ahead. Can you tell us what do you understand about crevice corrosion?
This crevice corrosion, it occurs like in a very tight space, like it's like a crack or something like that. It happens in between there due to humidity, sir.
So you haven't mentioned about the keyword. How crevice corrosion will happen normally?
Mm,
Okay, Ngan Chin Long. What do you understand about crevice corrosion? In what kind of operation or what kind of environment that you will see crevice corrosion? Calling for Ngan Chin Long. Yeah.
Oh, yes, sir.
Yeah. What do you understand about crevice? Where you will find, or under what condition you will most probably you will experience crevice corrosion. Okay, I've accidentally locked out from the system just now. Can you guys hear me now? Can you guys hear me?
Can, sir.
yes, sir.
Okay. All right. So so this is what we covered this morning. Crevice corrosion happen in when you have a welding process where there's a solution capture at the surface. Okay, keyword is welding. Okay, the next one is Filiform. Ngan, what do you understand about Filiform?
Filiform is the it happens at the coating layer below there. It forms something like a tree shape under the coating layer.
Okay. Under what environment? There's a key environment there. You need that environment to happen. Let's say you put a metal there. So you need what kind of environment?
Under humid environment.
Correct. The keyword is humid. You need a humid atmosphere to trigger the filiform corrosion. Okay. Yeah. All right. So just recap. Crevice corrosion. Normally in engineering, when you go to work later on, you cannot run away from welding parts. So this type of corrosion, sometimes if you work longer enough, you'll forget that crevice corrosion can be happen, right? Especially you work in welding industry, or you work in the oil and gas or pipe industry, where you need to connect metals and alloy together. Or maybe some of the you work in the product development department. One area that you need to consider for future maintenance, or when you select welding process in your products, then you need to be careful, especially when you become a manager, you employ a new welder, experienced welder or certified welder. They will avoid, because of their skill. They know how to control what is good welding and so on. So if you do not have a good welding skill, then this one will happen. Okay. So we have done introduce you a few type of a few form of corrosion, and we'll go deeper later on for SCC. Right. In SCC, need two key factor. One is tensile stress and corrosive environment. So corrosive environment means since the beginning of the lecture, I give you the general formula, right? So you need that environment, right? And also sometimes corrosive environment involve acidic and ozone. So you need that. Okay. Okay. So let's look at the second group, but another types. This one is more can fall under group 2, where you need a careful examination, and actually there's a micro crack already happened, especially this type of corrosion, or we call it intergranular corrosion, IGSCC. Intergranular corrosion. Again, recall what is SCC. SCC is stress corrosion cracking. So under stress corrosion cracking, it can be very small dimension. It can go up to intergranular corrosion, which fall under SCC category. So, or you can say intergranular attack happen when you have an impurity in your process, or when you make for example, microchip or microprocessor, the leg, the microprocessor, you have lots of leg come up from the microprocessor. So one of the leg may be when the supplier of that microchip, he buys something that come with impurity, then during the manufacturing, the impurity capture in the material. Then because of this, then you will see the microchip leg easily break. All right. So yeah. So the keyword for intergranular attack, why intergranular will happen, is because of impurity. Because you know that material have different properties. Some material very strong, or you become hard, or it is very hard properties. Some very soft. So when you mix hard and soft together, then or you become then when you have stress exposed to environment, then you have this kind of micro crack. This one is steel wire. Okay, standard steel wire. You will see there's a crack there. Okay, this one you cannot see with the naked eyes, but you will see something like why system soldering broke down, why there's a electrical shutdown, or you cannot turn on the machine sometimes. So it's because of the intergranular attack already happened in the system. Okay, normally this one, because it's intergranular means a very small dimension up to granular dimension. Once this happen, you need to change the component already, right? Yeah. So yeah. Another one will be, yeah, this one another example. Intergranular, again, intergranular is because of impurity in your material. So sometimes this one is another example in the welding area. Again, just now the welding area, another corrosion that can fall under welding condition is the crevice. However, it can be a combination of intergranular attack if you do not have a good welding skill, or you are using the wrong weld material, right? So this also will contribute to the intergranular. Intergranular, the focus will be on the granular dimension, which is you need to, this one very serious already. This one is a very drastic or extreme scenario where you can see the crack line already. Okay, so it normally happen at the granular dimension. Like you see, this is a granular dimension. You can see the element of the metals or alloy, right? You can see the rock, right? A rock shape under microscope. So it will happen in this one. This dimension we call micro crack. So we start from here, then it slowly propagate. Then this one will be a very serious case where with your naked eye, you can see the crack. So this one is too late already, right? So this one is stress corrosion. It's stress corrosion. But if you enlarge this, let's say you only study this area, you enlarge this one with microscope, then you will see some photo like this one. Okay. Next one is hydrogen embrittlement, HE. This one, let you see the photo first. Okay, so this one will happen in alloy. Okay, HE, hydrogen embrittlement. Embrittlement means it become solid, it become hard. The property become harder and harder, right? So you know metals are metals. It start with, if you learn about metal property, you know that metals, some metals is very soft. You can form a different shape at a room temperature, but when you bend enough, or when you give them some condition, the metal can become brittle, right? So this one, embrittlement, happen in alloy. So also it can mix with welding process, maybe casting. Casting, if you learn casting process before, casting involve temperature. So if you have the property graph of metals, you know that metals are, for example, Filiform diagram. So you know that forum have alpha phase, beta phase, and a gamma phase. So during casting, because of change of temperature, the molecule or the structure of forum change. So this one will happen. Okay, picking, cathode protection, and so on. And from the name itself, you see the element that trigger the embridiment, which is the hydrogen. Okay, so means hydrogen H2, it accumulate in the space, in the tiny hole in the structure. Okay, a more technical word means the hydrogen will hide inside interstitial lattice position, means it will hide inside the molecule, right? Inside the, not molecule, you can say molecule, but when you talk about metals, it's like a lattice or structure, right? So this is a very extreme example where you see something explode, then the metals open up like this. Let's see if I have the photo. This one is under SEM. Again, this one you can see there's a crack. But what is important when you have a HE, hydrogen embridiment, the hydrogen will hide inside all these hole between the lattice position. Okay, you see this small hole here. Sometimes hide inside this gap here also. This is under zinc. Right. So what is the keyword for hydrogen embridiment? The word hydrogen. How to make metals become brittle means become hard. So how metals become harder, or the flexibility reduce? How easily break metal? How easily break? Because the appearance of hydrogen, it accumulate in the hollow space, right, or in the defects. Then the hydrogen will make the material become harder and harder. So if you know that when you have a hard material, when you try to bend it, you will try to pull it under stress, then it will crack. So this is when you have a hydrogen element in your operation. Okay, when you, for example, if you're in the gas industry, you supply hydrogen, pure hydrogen. You supply from one place to another place, or you pump in hydrogen into a tank to supply to food industry, then this kind of defect will happen. Just be careful on the embridiment. Right? Another one is corrosion fatigue cracking. By looking at the name, I think you know how this cracking will happen. It combines two wording, corrosion and fatigue. So corrosion fatigue, you need a corrosive environment. And the word fatigue itself means you repeat loading on it. Okay, corrosion fatigue cracking happen. You need, from the wording itself, you can elaborate the corrosion or the attack by the first wording, corrosion. You need a corrosive environment. The word fatigue means you continue to load the material. So or you can use there's a cycling loading, right? So fatigue, it linked with repeating loading. So you repeat to load, to pull, release, pull, release, pull, release, or you press, release, press, release, press, release. Then, or you have a pressurized vessel. Pressurized vessel, when you have pressure, when you deliver water or deliver solution, when you pressurize, you know that pipe will expand, right? Because of high pressure, you expand. Then when the delivery done, you close the valve, the pipe will relax. So if this cycle continue to happen, it will expand, and then you close the valve, expand, close the valve. I mean, you open the valve, close valve, open valve, close valve. So you will experience cycling loading. Sometimes under temperature also, because you know metals expand under hot temperature and contract, right? When we have a cold temperature or lower temperature. So when you deliver a solution that can change the temperature of the material, also will contribute to corrosive fatigue, but you need a corrosive environment. So as long as there is a continuous loading, or there is the dynamic loading there, then it will be it can be categorized under this corrosion fatigue cracking. Okay, so yeah, this is what you learn in the materials module, right? When you have a cyclic loading or dynamic loading, then you will change the properties of the metals. It become brittle as you continue to loading on the material. It become brittle plus corrosive environment, then this cracking will happen. Right, this one you can, okay. So there are two wording that you might be confused, so that's why I put this statement here. Don't confuse with corrosive fatigue cracking and stress, what corrosion already? SCC, stress, apologize, okay. Okay, stress corrosion cracking, SCC, yeah. So don't confuse this one and SCC and don't confuse SCC, stress corrosive cracking, and corrosion fatigue cracking. So SCC only needs tensile stress, then it happened already. Sorry, not SCC, is FCC, right? CFC. Fatigue, the word fatigue, as long as you have tensile stress, fatigue will happen already. Okay, so just take note on this one. Okay, CFC and SCC, the only differences is that if you in your system, if you have tensile stress, then CFC will happen. Okay, the only requirement for CFC to happen is tensile stress. Okay, so take note. This is a very tricky area where you might confuse, especially when it comes to long question in final exam. Ask you to explain. I'll give you a scenario, and then you explain why CFC will happen in that condition and not SCC. So this is the catchword. Okay. So CFC or corrosion fatigue cracking, this is another example in the structure that you will see there's a crack in the red arrow there. This one, right? There's a crack there. So as long as there's a tensile stress, there's a pulling stress, especially when you have this corrosion fatigue cracking usually will happen at the connecting component, where there is a connecting component that you need to lock two mechanisms together. And this two mechanism is actually having a a pooling effect, means you are experience at the connector connection area itself, it has tensile stress. So especially the screw area, right? The screw area, normally you have that fatigue happen. Okay, the rest you can read from the slides. This one is under microscope. You can see the crack will happen. This one under copper. This is copper tube that happen in the subcooler, right? In the chiller or subcooler. Okay. Any questions so far? Any question?
No, sir.
Okay. We'll go for a short break, then we come back, right? We end the recording.